In this video, I want to talk about tangent, the inverse of the tangent function, and how to use those to solve for missing angles and missing sides. So in the first problem here, we're going to look at, I'm going to look at solving for a missing side. So we have this missing side x, right over here, missing side x. First, it's important to remember what tangent means, what tangent represents. So for any right triangle, and obviously we have a right triangle here, there exists this ratio between sides. So if I know an angle, so I know this angle is 48 degrees, this ratio of the opposite side over the adjacent side has to be the same number. It doesn't matter how big or small the triangle is, that ratio of sides is dependent upon the angle. And our calculator will tell us what that ratio is. And that's the idea that we use to solve for a missing side. So we can set up an equation here like this. So we know that the tangent, well, it's a little bit, let me just change that really quick. The tangent of a 48 degree angle is equal to the opposite side, opposite over adjacent, right? So tangent is always the ratio of the opposite side over the adjacent side. So in this case, that's x over 15. And it's really important when you do, when you go to do a calculation, that your calculator is in degree mode. We're working in degrees. If your calculator is not in degree mode, you will not get the correct answer. So from here, we're going to use that calculator function. Our calculator will tell us what this ratio is. It'll tell us what the tangent of 48 degrees is. So we punch that into our calculator, making sure that we're in degree mode. And we find that the tangent of 48 degrees is equal to 1.11. I'm rounding a little bit here, but that's okay. Usually 2 decimal places is appropriate. And that is still equal to x over 15, right? So we know the ratio is 1.11, and that is equal to our missing side x divided by 15. So we just have one step now to find that value of x. Since we have x divided by 15, we can just multiply both sides by 15 times 15, and we will get our solution. 1.11 times 15 is equal to 16.66 approximately, and that is equal to x. On that right side, we have 15 on the top of our fraction, 15 on our bottom. Those would create a 1 and essentially disappear. So this is your basic formula. You're going to set these equations up always the same way. Sometimes you might have your x in the bottom of the equation, right? If your x is in the bottom of that fraction, that makes one more extra step for solving, but setup is the exact same process. The other thing we can do with tangent, with the inverse of the tangent function, is we can use that to actually find angles, right? So we'll look at this right triangle here, and we could do this for any of these angles that we wanted. So first of all, we'll do angle x, right? So the measure, we want to find the measure. I'm going to go back to blue, the measure of angle x. And the measure of angle x is equal to the inverse tangent. So tangent gives us a ratio of sides, and the inverse tangent will give us an angle. So if I plug into my calculator what that ratio of sides is, the calculator can basically do the inverse function and use that to find the angle. So the measure of angle x will be equal to the inverse tangent. So that's tangent -1. It's also written as arctangent. So these mean the same thing. Tangent -1 of, and again, tangent is still opposite over adjacent. The opposite side of x is 27. Right? This is the opposite. The adjacent side to x is 36. And students often ask, well, why isn't this 45? Why isn't that the adjacent side? It's still next to my x. And it's really important to recognize that this side is actually the hypotenuse. Right? The hypotenuse of the triangle can never be the opposite or the adjacent. The hypotenuse is always the hypotenuse. I'll just write hypotenuse over here. If I could spell it correctly, hypotenuse. There we go. So, again, going back to our problem, the measure of angle x is equal to the inverse tangent of the opposite is 27, over adjacent, which is 36. And we could, if your calculator says arctangent as well, it'd be the same thing, 27 over 36. So if we punch that in, inverse tangent of 27 divided by 36, and I often use that divided key on the calculator. Sometimes calculators don't work very well if you write that as a fraction in there, but division always works, and that's the same thing as a fraction. So I punch this in, I get 36.87. Again, I'm rounding to 2 decimal places. So the measure of angle x is 36.87 degrees. I'm just going to write that over here, 36.87. And if we wanted to solve, I'll just set it up really quickly. I won't punch it into the calculator, but if we wanted to solve for angle z, right, we could do that as well. So the measure of angle z is going to be the inverse tangent of the opposite over adjacent. And now in this case, the opposite of angle z would be the 36, and the adjacent would be the 27. Remember, it can't be the hypotenuse. So tangent inverse of 36 over 27. And if we punch that into our calculator, we will get 36 divided by 27. We get 53.13. And an easy way to check that this is right, since this is a right triangle, these two numbers better add up to 90 degrees, right? Because the whole thing has to be 180. And if we do just look and quickly check, those do add up to 90 degrees.